Well, welcome back to science class. My name is Mr. Sportell and I will be your teacher today. It's the last lesson before spring break. What a wonderful, wonderful time when we get to stay home and not do schoolwork. Hope you're looking forward to it. But before we do that, I want to go ahead and recap some of the stuff that we've been doing for the past few weeks and give you some things to think about as you head off on this break. Now, first, what's the difference between distance and displacement? So if I were to go ahead and draw out on this board maybe a possible adventure. Here you are in your house, and then you decide, I've run out of toilet paper, because we may have just done that. You run off to the store, big box store there. Then you run back to go for a nice walk. Then you go back home. Let's say this is 10 miles, this is 10 miles, and this is 5 miles. What is your displacement for this trip? And what is your distance? Your displacement is 0, and your distance is 25. Hopefully you got that right. So, the next thing to think about. What's the difference between speed and velocity? Speed is how fast you're going. The velocity is how fast you're going in a direction. That's the only difference. And it seems silly. And I agree, sometimes physics is a little bit ridiculous. But the idea is that you'll be able to tell, am I going towards, am I going away? Because when you get to velocity graphs, that's going to make a huge difference. Because am I going above the zero line or am I going below the zero line? Now, a couple of formulas that we've kind of hit on that I just want us to remember, and so we know how to use. The formula for velocity. Velocity is distance divided by time. Okay? Now, the distance might be in any sort of unit, meters, miles, whatever the case may be. Time might be in hours or minutes or seconds. You just need to make sure you know what it is that the answer needs to be in. Because if I give you minutes and I'm asking for miles per hour, you're going to have to change it. So just be very wary of your end units. Okay? The next, what's the formula for acceleration? Change in velocity over change in time. For you fancy math people, that means delta velocity, delta time. Change in velocity over change in time. So if I've gone from 0 to 15 meters per second in, let's say, just 10 seconds, I'm going 1.5 meters per second every second. Make sure you use the right units for acceleration as well. Then, it's really time to talk about graphs. Some of you have not been watching these videos. I like to look and see how many people have viewed my videos. It's always disconcerting to know that there are about, I don't know, 1/5 to 1/6 of you who haven't even watched the answers. So you really don't know. And then there's another chunk of you who didn't even watch the first video. I really don't know how to help you any other way. If you have ideas, please let me know. I'd be glad to help. But we've got these wonderful flashcards. Make sure you understand them. You might, I don't know, want to look over them maybe once a day over your spring break. Maybe sometime during the day you're just going to say, okay, standing still. What's that look like? A position time graph, velocity graph, and acceleration graph. Moving toward and speeding up. What's that going to look like? Do you know, top of your head? Moving toward, speeding up. Did you say it was this? Then you were right. It'd be a good idea to keep practicing those. Make sure you try and figure out the difference between what's it going to look like as a position time graph versus the velocity time versus acceleration time. There are essentially just that constant position, which is going to be standing still. There's a constant velocity, which is things like this, moving away at a constant rate. That's when you're going to have your velocity be a flat line. And then there's going to be your constant accelerations, which would be things like moving towards, and speeding up. so you have your constant accelerations. Maybe I'll give you like a big graph, and what you'd have to do is you have to figure out the different chunks, kind of chunk it up, and then produce for me velocity time graph and acceleration time graph from a position time graph. If you do that, you really need to just pay attention to break them into these little pieces. There's 7 of them. With practice, you'll be able to see them. You'll be like, hey, I know those pieces. Chunk them up, change them up. You've produced a graph, just like that. Okay? That's my suggestion. Today, right now, I want you to go ahead and practice your flashcards 10 to 15 minutes. Then, over break, 5 to 6 times, spend 5 minutes. Because remember, you don't remember what you want to remember, you remember what you think about. Okay? There is some homework posted on Moodle for the break. Now, it is voluntary. It's things like help out around the house or, things like that. But I really just want you to do things that are going to benefit people in your life. Things like write a letter to a grandma or a text if your grandma texts or whatever the case may be. Just pay attention to those people. Find people in your life that need you, that need a word from you, that need that social piece that they're missing. That's what I want you to do over this break. So, be safe, have fun, and I'll see you back here when it's all said and done.